Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here. I just wanted to take a second to show you exactly why I do the whole like hat deal. Freshly shaved head last night. Just look at the shine right here on my head, how shiny this is with the light directly overhead. So my daughter thought it'd be funny. She wanted me to wear this hat. So this is her pink hat that she wanted me to put on, which definitely does not fit very well. But hey, I make this look good. What do you say? Hey. Anyways, so in this video today, what we're going to be talking about is chapter 8.2, which is dealing with arithmetic sequences and partial sums. Should be an easy one, just a couple of formulas and applying those. So let's kind of jump right in and get started here. My recommendation is wait till the end of the video as well, or jump to the end, because there's a problem that I know everybody struggles with that I forgot to add to the notes. So I went ahead and just kind of wrote it in at the end of the notes here, okay? So let's get started. So what you should recognize when all is said and done with this section is how to write the nth term of an arithmetic sequence, how to find partial sums, which means we're adding up a certain number instead of an infinite number of values. And then we're going to use arithmetic sequences to model and solve real life problems. Okay? So when we're talking about an arithmetic sequence, we call it this because we have this thing called a D, which is a common difference that's taking place between a problem. And in order to find that common difference, what we do is we generally look at two terms and we figure out what's the difference between them, by taking the second one and subtracting the first one from it, okay? And so that D is the common difference which we're seeing taking place. I told you guys before, that's basically like the slope when we're talking about y equals mx plus b. So when we look at this, if we were to say like this is y equals mx plus b, you can clear as day see that the change, the difference that's taking place in this is a slope of 4. So if we were to say, well, let's find the common difference between the consecutive terms. We know it's 4. What does this look like if we go ahead and start listing out terms? Well, what we would say is a of n is equal to 4n plus 3. This is our rule. So if I say, well, what's the first term in this series? You'd say 4 times 1 plus 3. And what you'd find that this is equal to 7. And then once I find the second term, we would go and do 4 times 2 plus 3, and we would see that this is equal to 11. And so if this is 7 and this is 11, we can see clearly that the difference between these two, 11 minus 7, is equal to 4. And that is exactly what we end up with when we go ahead and list out all these values that take place. So we've got our first term, our second term, our third term, our fourth term, and so on and so forth. And what's happening is we're getting a common difference of 4. So I could just, now that I know the common difference, instead of rigorously putting them in, I could just go ahead and keep adding 4, keep adding 4, keep adding 4 to these, okay? So the same holds true when I have something like this, where we have, remember, I said it's y equals, basically like that, right? We can look at this and know that the slope of this is equal to -5 for the common difference. So the slope is -5. And so what happens is we plug in the first term. So if I plug in 7 minus 5 times 1, we end up with a positive 2, because this is my first term. Oops, sorry, I meant to delete that. This is my first term here. So this is A1, this will be A2, this will be A3, this will be A4, right? And so if I go ahead and put in my first term, 7 minus 5 times 1, that's where we get that 2 from. And then if I say, well, this is my second term right here, this is A2, then I would put in 7 minus 5 times 2. That's where I get that -3. But once we recognize that's an arithmetic sequence, we could go ahead and just keep doing that slope, taking away 5, taking away 5, taking away 5, in order to get all of our values. Some of them are not so obvious. So when we look at something like this, the 1/4 times n plus 3, if I was to go ahead and rewrite this in its standard slope-intercept form, this would be y is equal to 1/4 n plus 3/4. Okay? And if I was to say, in terms of our rules, we would say a of n is equal to 1/4 n plus 3/4. So it would look the same, right? If I want to find the first term, what I do is I go ahead and put in a 1 right here for this n, and we have 1/4 times 1, which is just 1/4, plus that 3/4. We end up with our first term being equal to a 1. And then when I use my slope, I just add a fourth, add a fourth, add a fourth, and I keep doing that. Now, when you get to fractions, they don't always look so obvious because of the fact that my denominators are the same. But think about how you can actually write these so they do look exactly the same. This one I can write as a 4/4, so it has that denominator of 4. And then we have a 5/4. This 3 over 2 I can write as a 6 over 4. And then we have a 7 over 4, and so on and so forth. And it's a lot more obvious here to see that the slope is actually increasing by 1/4 as we move across here. So whenever you have denominators that are different, see if maybe you can get them to be similar before you go ahead and move forward. If you can't, then it is what it is. We'll come up with a different rule, okay? So in arithmetic sequence, how do we find these and how do we use them? Well, the formula is this. This is makes things a lot easier when we actually know this formula. That the rule, so a of n, just like y, is equal to whatever my first term is, plus n, which is the number term that we're talking about, minus 1, times d, which is our common difference. So this is our formula that we're using to find a rule for the nth term in an arithmetic sequence. When we're talking about finding a partial sum of an arithmetic sequence, this is the formula we say. We have S of n is equal to n divided by 2, and then a1 plus a sub n. Each one of these things represents something in particular. That S of n is saying the sum of n number of terms. N stands for how many terms. A1 is my first term, and an is the nth term in our series. So let's look at what these look like in action. So if I was going to say, find the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19, this is one where it's actually pretty quick and easy to do it because we can see an obvious pattern, or hopefully you see an obvious pattern form, where we have right here 1 and 19 is equal to 20, 3 and 17 is equal to 20, 5 and 15 is equal to 20, 7 and 13 is equal to 20, and then 9 and 11 is equal to 20. And what happens is you can kind of see the formula taking place here, right? That when you look at how many terms there are a total of here, there's 10 terms. But what happens is there's 5 sums that take place. And so we have 10 divided by 2, which is going to equal 5. And then we say, well, the sum of 1 plus 19, because that's my first term and my last term in the series, that means we end up with 10 divided by 2 times 20, which is 5 times 20, or 100, which we can see is the sum right here. So that's kind of the formula in action. So let's plug in those values so we can actually see it, okay? So when we say a of n, or s of n, n over 2, a1 plus a sub n, okay, what we're going to do is we're going to plug in, we know that there are 10 terms here, so we're going to say 10 divided by 2. My first term is equal to 1, and my nth term, which is my last term, is equal to 19. That's that formula we just said. So let's watch this in action so we can simplify it. We get 10 over 2 times 1 plus 19. We go 5 times 20, and we end up with 100 for the total sum taking place in this problem. Okay? So when we say the sum of a finite arithmetic sequence, we're saying take the partial sum, a portion of the overall value that's taking place in the problem. So we can use this in bigger picture problems here. Like let's say I was to look at a small business, okay? They're going to sell $20,000 worth of sports memorabilia during its first year. Okay, now there's key words that are taking place here, right? They say first year, $20,000 worth of sales. The owner of the business has set a goal of increasing, so we're talking about, in this case, we're talking about like a common difference. We're increasing by $15,000 each year for 19 years. So they're giving me more information. They're saying that we're going to do this over the course of 19 years. Assuming that the goal is met, find the total sales during the first 20 years. So they give us another clue here. They're saying, let's find the total sales, which means we're finding the sum. So what does all this look like when we put all this in? Well, they're giving us information. They said the annual sales form an arithmetic sequence, the annual sales form an arithmetic sequence because my first amount that we start with, as we said, is equal to 20,000, right? So that's 20,000 right here. We say that the common difference, how it's increasing, is 15,000. So we can write a rule for this. We have our first value. We have our common difference. What would that formula look like? It's going to be A1, which is 20,000, and 15 for our common difference. So we got A1 here, and then we got our common difference here. Okay, so this helps us to generate a rule. Okay, so once we know what the rule is, this is the rule in simplified form. Distribute the 15,000 combined like terms. So once we know what the rule is, we need to find what the 20th term is in the sequence because they're asking after 20 years, what's the total sum? Okay. And so we have to go ahead and find each one of these values. So let's put in 20, and that means we're going to have 15 times 20 plus 5,000, which means we'll have 300,000 and then the 5,000, so 305,000. That's the total amount that is going to be acquired during that last year. So again, total sales during the first 20 years means we're going to add everything together. The first thing we just did here was we found what is the final amount during the last year of my 19 years. So if I start off, I'm at year 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 times. Okay. So we now know during the first year how much we had. We know during the 20 or the last year how much money we had. Let's go ahead and put these in our formula for the sum. The sum of the first 20 terms is Sn equals n over 2 a1 plus an. We know that there's going to be 20 total years that are going to take place. So we say 20 divided by 10. During the first year, we had 20,000. And during the last year, we had 305,000. Okay. Simplify it, we have 10 times 325,000, so we have 3,250,000. So that means that the total sales during the first 20 years is a total of 3,250,000. Okay, so this is how we apply the formula. And you can't do the formula unless you know each and every single one of the values. The first amount, the last amount, how many there are. Okay. All right, so that's pretty much the formulas in a nutshell. Now, there's one that I said that you guys should really go back and jump ahead and watch this if you didn't want to watch the whole thing. But make sure you guys copy this down because this is probably the most confusing part. So let's link it back to something you guys know and understand, okay? If I gave you an equation, and I'm sorry, if I gave you 2 points and I said you're given the points 3.8 and you're given the point 7.6, and I would like you to find an equation in y equals mx plus b form, what would you do? Hopefully, you would jump right to the knowledge that you guys have, which you know is going to be to go ahead and find the slope first, right? If I ask you to get y equals mx plus b, you're going to get the slope first. So 16 minus 8, 7 minus 3, divide, we get that the slope is 2. Hopefully then, the next thing you would say is, well, let's go ahead and put this in point slope form. Point slope form, if I chose the 0.38, I'd have y minus 8 equals 2 times x minus 3. Now, I could technically just take this 8 and move it over, and I would have y is equal to 8 plus 2 times x minus 3. And that would technically be an answer, right? That would be a formula that I can use to find all the points given slope-intercept. But if I continue on with this, I keep distributing and then simplifying, I get that y is equal to 2x plus 2. Now, why am I showing you this? I want you to understand that these problems that we're doing are very similar to things that you've done already in the past. In fact, they're identical. It's just that we don't use x and y. We're talking about using n and the nth term, right? So the first being this value, the third being this value, the seventh being this value. So what does that look like in a problem like in this unit? Notice here that what I'm giving you is a coordinate 3.8, but I'm saying the third term is equal to 8. The seventh term is equal to 16. Okay, so there's a similarity there. So how do I go ahead and solve for this? Same way you would always do it. You would go through the normal steps, find the slope between these. The common difference, though, is what we would call it. Same thing as slope, right? Then you would pick a point. So if I pick a point, we know the formula is an equals a1 plus 2 times n minus 1. So if I go ahead and substitute in that coordinate, that 3.8, here's what my formula would look like. Looks pretty similar, doesn't it? And if I continue solving for the first term in the sequence, we would have a1 is equal to 4. Okay. And then I can go ahead and put in my a1 value is equal to 4. My common difference is equal to 2. And then what we would have here is 4 plus 2n minus 2. And if I simplify that, we end up with 2n plus 2. which you should see are the exact same equations as if I had done it the other way. So you can see there's similarities here between everything. That is it, everybody. This section is supposed to be pretty straightforward. Just go ahead and practice using those formulas. Anytime you're not sure, try to use maybe slope intercept, but overall, this should be a section that you guys just crush, okay? Until then, you guys take care and be safe, and don't forget to like and subscribe to my channel. We'll see you next time, okay, Mustangs?